Okay guys, here's your video for lesson 18T, applying the Pythagorean theorem to real life situations. So for number one, your instructions are, says draw a diagram and solve for the missing measure. Round to the nearest tenths place. Number one, a car travels 40 miles west, then goes 30 miles north. So on your diagram here, the car is going to start this way, and it's going to go 40 miles, to the west. Okay, so 40 miles. Then it's going to go 30 miles, 30 miles to the north. It says how far is the car from its starting point. So what you want to do is you want to find out, so if this in red is its starting point and this in blue is its end point, you want to find the direct line, or the direct distance between those two points. So all you do is you just use Pythagorean's theorem. Remember that they give you the length of the legs, and it's up to you to find the length of the hypotenuse. So you got a squared plus b squared equals c squared. Plug in what you know. We've got 40 squared plus 30 squared equals c squared. 40 squared is 1,600 plus 30 squared, that's 900, equals c squared. 1,600 plus 900 is 2,500, and that equals c squared. Next thing I'm going to do to get rid of the square, I'm going to take the square root, and I end up with a hypotenuse c being equal to, what's the square root of 2,500? That is 50. And what is my unit of measurement? My unit of measurement is 50 miles. Okay, so that is the distance from my starting point to my end point. Okay, on to number two. Okay, on number two, it says a 10-foot ladder leans against a wall. It hits the wall 9 feet up. How far is the base of the ladder from the wall? So here you got your ladder, put it in blue. Okay, and it hits the wall, so this is a 10-foot ladder. So they give us the length of the hypotenuse. And it hits the wall 9 feet up. They want you to find the length of the leg, or the length of the base, and find out how far the base of the ladder is from the wall. So you've got to find out what one of the legs is. But you still start off with Pythagorean's theorem. So here we go. You've got a squared plus b squared equals c squared. The length of one of my legs is 9 feet. The length of my other leg is the unknown. And the length of the hypotenuse is 10 squared. So 9 squared, that's 81, plus b squared equals, what's 10 squared? 10 squared is 100. Subtract 81 from both sides, and I get b squared equals 19. Take the square root of both sides, because that undoes my squaring, and I get a value of b equals something like 4.1 or something like that. But let's check it out. It's actually 4.4 after you round it. Okay, so it would be 4.4 feet. All right, on to number three. On number three says a rectangular window is 2 feet by 3 feet. Approximately how long is the window's diagonal? So let's go ahead and start off by drawing ourselves a picture of a rectangular window. So there we go. Let's go ahead and label what we know. It's 2 feet by 3 feet. And they want us to calculate the window's diagonal. So that's the length of our hypotenuse, because it's the side that's opposite the right angle. Okay, here we go. So we've got a squared plus b squared equals c squared. Good old Pythagoras and his beans. So we've got 2 squared plus 3 squared equals c squared. 2 squared is 4, 3 squared is 9, equals c squared. Let's go ahead and do this over here. So 9 plus, actually we'll do it over here. So 4 plus 9 is 13. So I've got 13 equals c squared. And I take the square root of both sides. That undoes my squaring. And c equals the square root of 13. After I round it, is going to be 3.6. So 3.6 feet. Remember, check my work, don't trust my work. Okay, on to the next page. Number 4, it says Jenny walks 9 blocks south and 5 blocks west. Approximately how many blocks is she from her home if she were to take a direct path? So I'm going to go ahead and put a dot and say that's where Jenny walks. That's home base, right? So there's home. So it says she walks 9 blocks south. So 9 blocks, right? And then she goes 5 blocks to the west. So never eat soggy waffles. So we've got 5, oops, that's a sloppy 5. So we've got 5 blocks in that direction. Okay, so then there she is. So she stops off at the park. Okay, so we'll say P for park. So it says approximately how many blocks is she from home if she were to take a direct path. So here's my direct path. Okay, just like that. Well, how about just like that? Okay, so we're going to find the length of that hypotenuse. Good old Pythagorean and his beans. A squared plus b squared equals c squared. And if you want to know why I refer to the beans, look up Vi Hart's video on the Pythagorean theorem and Pythagoras. It's kind of interesting. Anyways, I digress. Okay, the length of one of my legs is 9. We're going to square it. Plus the length of the other leg, which is 5. I'm going to square it. Equals the length of the hypotenuse squared. 9 squared, that's 81. 5 squared, that's 25. We're going to add those, and that's going to equal the length of my hypotenuse. At this point, we're going to go ahead and add. So 81 plus 25, that's 106, equals c squared. I want to find the length of that hypotenuse, so I got to take the square root, and I get c equals, and let me clean this up a little bit, right underneath. So I got c equals the square root of 106. Okay, after I round it, it's going to be 10.3 blocks. Okay, there we go. Again, check my work, don't trust my work. So 10.3 blocks for number 4. All right, number 5. It says a rectangular prism is 3 inches long, 4 inches wide, and 8 inches tall. What is the length of its longest diagonal? So unlike the other problems, we're dealing with a 3-dimensional object here. So we're dealing with the Pythagorean theorem in a 3-dimensional space. So what you're going to want to do is you're going to want to make this look 3-dimensional by adding in the dashes. So what you're looking for is the length of the longest diagonal. And the longest diagonal goes from one point or one vertex to the opposite vertex on the opposite wall. Okay, so I'll see if I can demonstrate this. So if I was to go to this vertex right there in the front upper left to find the longest diagonal, I would want to go to the vertex that is in the bottom lower right, this right here. So think about it, if I was to shoot a string across from one side of the room to the other side of the room, okay, through the middle of the room, that would be its longest diagonal. Okay, so here we go. So this is an applied version of Pythagorean's theorem. So you've got 3 squared plus 4 squared plus 8 squared equals d squared. 3 squared, that's 9, plus 4 squared, that's 16, plus 8 squared, that's 64, equals d squared. 9 plus 16 plus 64 is 89, equals d squared. So to find the length of that longest diagonal, I'm going to take the square root of both sides. And the square root of 89 is, after I round it, so d equals 9.4. And there is a unit of measurement, and the unit of measurement is inches. So my final answer is d equals 9.4 inches. All right, that's it. Pretty simple, pretty easy. At this time, let's go ahead and get out a piece of paper, a pencil, and a calculator. And let's go ahead and get ready for today's assignment.